Now the machine needs to be jogged to determine the direction of each axis. You can do this by pressing one of the axis buttons, Y plus, Y minus, X plus, X minus, Z plus, Z minus. Make sure that the machine is in a position that it won't go to the end of a particular axis or hit the limit switch of an axis. Now we're going to jog the motors. We're going to set it to 1 millimeter under jog mode and set the XY feed rate to 2000 millimeters per minute and the Z feed rate to about 800 millimeters per minute. And we can now start clicking the arrows to move them around. Okay, the X is working. Let's try increasing to 5 millimeters. Good. X minus, I'm clicking X minus and clicking X plus. And I'm going to click the Y. That should move the table. For the X and Y axis, if the particular axis appears to be going away from the limit switch and you're pressing the plus, that means that it is going into the plus direction and you are okay. If it appears to be going in the opposite direction, that particular axis needs to be inverted. Since the Z-axis limit switch is at its maximum position, the opposite would be true. To do this, go to Machine, Motherboard, Onboard Preferences, and you're going to select the particular axis that you want inverted. In this case, my Y was inverted, and I want to uninvert it so it moves in the correct direction. To invoke these changes, you'll need to reset the motherboard. When completed, jog the machine again and make sure that the axes are moving in the proper direction. Now that we have confirmed that the axes are moving in the proper direction, we can go ahead and home the machine using the homing at the top left corner of the control panel. I am starting out with the X-axis. You can watch the axis move until the axis hits the end stop position. Keep your mouse on the stop button just in case the axis is moving in a way that is not intended. So first we're going to try to home the X-axis. To home Y, click homing, home Y to minimum. And now we'll home the Y-axis. And finally we'll home the Z-axis by clicking on homing and homing Z to maximum, since we're going all the way to the top of the Z-axis. Now we will try to home the Z-axis. Okay, and that worked. Now we need to go through a process that allows us to find out exactly what the Z height is from where the Z hit the end stop at the very top. That's Z maximum. And we're going to either manually or jog the Z-axis down to a point just above the table surface, and it should be just a hair above the table surface. The number that will show up on the Z-axis is the number that you'll be plugging into a G-code file that will allow the machine to travel down to just above the table surface to start printing. We will use a G-code script under File, Scripts, Calibration, Thingomatic Calibration.G-code. You will notice under the G-code tab that a G-code set of instructions is displayed. Now we can execute the G-code by going to G-code and Build. We will be presented with a few instructions on how to proceed. 1 millimeter increments and go down till it's just above the table. It should just be a hair above. And that looks like it's close, right there. So that is set. Now it's moving up. I'm assuming it's going to stop when it gets to the end stop. Yes. So it's moved up all the way to the top where the end stop is. So we need to find the maximum Z height. Going to the control panel. The maximum Z height is 131.5, so we need to write that down. Now we're going to test the consistency of the PLA coming out of the nozzle. We're going to bring the nozzle up to
205 degrees Celsius and start from there.
So the first thing you need to do is add the filament here. You just open this and push the filament, the PLA, into the red PTFE tube and close this down, and it should be located in the serrated hub that I have on the shaft of the stepping motor. And then all you do after that is take a rubber band and rubber band this hinge down. You want to try to get it pretty tight. Okay.
Now we'll use the control panel to draw or push the PLA filament into the tube and draw it out of the nozzle and check the consistency using the forward button.
Now I'm going to press the forward button since we have the desired temperature. See what happens. So we are pushing out some PLA. I'm going to go forward a little bit. Yep, and it's coming out. And it looks like it's a nice stream. Yes. Now we can go ahead and create the calibration cube.
There's one more file that's required for the profiles for this machine to be used with the whiteAnt and Replicator G. And go to buildyourcnc.com and click CNC Machines. We're going to go to the whiteAnt. We're going to get the whiteAnt specific machine SkyneForge profiles. So just click that, or actually let's see, we just click it, yeah, and then it will download for you. And what we're going to do is we're going to take that file Okay, you want to put the whiteAnt SkyneForge profiles. It's going to come up with the whiteAnt folder. You want to put that in Skyne Engines, SkyneForge 35, which is what we're using, SkyneForge application, and you go to Prefs, and we're going to put the whiteAnt in the Prefs subfolder. Now next we need to go into the whiteAnt, go into the alterations folder, and then you want to make a change to the start G code. Since we want to edit it, we're going to just go ahead and open, and it's going to give us a screen like this. Select a program, and we're just going to use Notepad to edit the file. Now we're going to look for where it says G92 Z100. I'm going to edit, find, and look for G92, and we found it. And here we're going to set the Z to the number that you found when you were calibrating the Z-axis. And the number that I found was 131.5. I can save the file. If you haven't done so already, this is the time to install Python. Click Next, Install for all users, if that's what you want to do on your system. Select a location and wait for it to install. And click Finish. And to be able to print using SkyneForge, we need to have our own profile. Before we can print, we need to download something to print. So we're going to go to a place where there are many, many models to choose from. Thingiverse.com. And the thing that we're going to get is the one located at 5573. And that should be a 20mm box to use to see if we have our machine set up correctly. And all the way at the bottom you'll find the files. We're interested in the 20mm box STL. Just press the download. Now we have it in our download section. We can go ahead and open it up with Replicator G. Now start up Replicator G. We're going to open the 20mm box generator. Just go to G code, choose G code generator, and make sure that SkyneForge 35 is selected. If it's not, go ahead and click on this. And then we're going to generate G code. We're going to select the whiteAnt that was just created into that subfolder and press generate. And we can go ahead and build it by pressing the build button. The machine will sit at this position until the software determines the nozzle has reached its target temperature.